Hey everybody, so today we're going to be learning about geometric sequences, which is picking up off of what we learned last week or 2 weeks ago with arithmetic sequences. So today's learning target, this is when I would call on one of you to say the learning target, but since we're learning remotely, this will have to do. Today's learning target is I can apply the definition of a geometric sequence by finding a specified term and constructing the nth term. So this is similar to what we did last week with arithmetic sequences, but what we're doing today is we're going to be learning about a different type of sequence, the geometric sequence. So what I would like you to do right now, even though I can't make sure you're doing this, is to please say geometric sequence at least 2 times. We need to be familiar with the vocabulary. So the definition of a geometric sequence is, it is a sequence of numbers where each term after the first is found by multiplying. So all we're doing with geometric sequences are multiplying. Make sure that's a key note. We are multiplying. If you want, put a big exclamation point next to it, a smiley face, whatever. You are multiplying. And you're just doing this by multiplying the previous number by a fixed non-zero number. When we say non-zero, we simply mean we're multiplying by a number that's bigger than 0 or smaller than 0. Wait, that's crazy. We don't multiply by negative numbers often. Who cares? And that number is called the common ratio. Common ratio. Let's underline that. And we denote this in math by just writing the letter R. This is our common ratio. Okay? You're going to notice, just like last week, that geometric sequences are similar to arithmetic sequences, except geometric sequences aren't just special functions, they are exponential functions. We just did a whole unit on exponentials, because that is what a geometric sequence is. They are exponential functions, which means that they grow very, very big and they grow very, very small very, very quickly. 1 second, I just had to text someone. Okay? So again, now we're going to look at the general form of a geometric sequence. You do not need to memorize this. This is provided on your reference sheet. The formula is, I'm going to say this once, and I'm going to ask you to please say this at least once or twice. If you need to hear me say it, just rewind the video. The general form of a geometric sequence is a sub n. Again, I said a sub n. A sub n is equal to a sub 1 times r to the n minus 1 power. A sub 1 is simply your first term. Your first term. So basically, I look at a sequence and I just look at my first term and I put it in for a sub 1. And R is our common ratio. R is our common ratio. We're going to write that in. And it's just the number you multiply by. Okay, so a sub 1 is our first term, and R is our common ratio. It is the number you multiply by. So again, I'm going to ask you to say the general form of a geometric sequence formula one more time. A sub n equals a sub 1 times r to the n minus 1. All right? So we're going to do a practice problem together. After we do one question, after we do this example, after we do this one together, this whole question, where we answer, is it geometric? Is there a common ratio? Is there a formula? I would like you to try the next two by yourself. If you still need a little more assistance, watch me do the second question, and then try the third one by yourself. But again, after we do this question, I'm going to ask you to pause the video. Okay? So, what happened? Oh no. Technical difficulty. Is there an erase button? Oh, there is. Thank Jesus. So let's do this question together. Mr. O'Sullivan was very, very worried that he lost everything and he would have to start from scratch. So for question number 1, we start with the sequence 2, 6, 18, and we want to find the second two terms. So just so we can start with some of our language that we've been building over the past few weeks. Few weeks, since it's been a while. Let's just say this is our first term, our second term, and our third term. Now I want to find term 4 and term 5. The first thing we need to ask ourselves, how am I multiplying from 2 to 6? I can just do 6 divided by 2, and I get 3. That is my common ratio. I'm just multiplying by 3. And I can double check myself. What is 6 times 3? Boom, it's 18. So now I ask myself to find my next two terms. What is 18 times 3? That's when I would simply ask one of you to take out a calculator, but since I'm not here to yell at any of you, I'll just tell you, 18 times 3 is 54. And then we ask ourselves, what's 54 times 3? This is when you all shout out at once, 162. Those are our next two terms. So it is geometric. And the reason why it's geometric is because you multiply by the same value each time. We said this before, our common ratio is 3, or R equals 3, because we multiply by a 3 to get each new term. I did 2 times 3, which is 6. I did 6 times 3, which is 18, and then so forth. Now comes the hard part. How do I write a formula to represent the sequence? The first thing I ask you to do every single time is to rewrite your formula. A sub n equals a sub 1 times r to the n minus 1. A sub n, we now need to go back to our sequence and look at what our first term was. Our first term was a 2. So I'm going to put that in for my first term as well. I now ask myself, what did I multiply each time by? And I answered it before. I multiplied by a 3 each time. And then I raise it to the n minus 1. Winner, winner, chicken dinner, that is your final answer. My formula is a sub n equals 2 times 3 to the n minus 1. And yes, those parentheses are extremely necessary. If you would like to right now, I'd recommend you take a pause of this video and attempt the next two questions. If you would like, you can stay on and watch me complete the next question. But I would then encourage you to try the third question by yourself. Question number 2. It is geometric. I'm telling you right now, all these sequences I'm giving you are geometric. And the reason why it's geometric is because I now have to figure out my common ratio. I multiply negative 20 divided by 4, and I get negative 5. Negative 20 times negative 5 is 100. 100 times negative 5 is negative 500. And negative 500 times negative 5 is 2,500. So I get 2,500 as my last term. I ask myself what the common ratio is, which is simply the number I multiply by each time. We did this together. The number you are multiplying by each time is a negative 5. So I simply do r equals negative 5. Okay. I now write my equation, and I start from the beginning. A sub n equals a sub 1 times r to the n minus 1. I look at my sequence again, so I'm going to zoom back up. My first term is a 4. That is going to be playing a major role in this equation. So I get a sub n equals 4, parenthesis, I go back to my previous answer, my r. My r was negative 5. And I raise it to the n minus 1. That is your final answer, or my final equation. A sub n equals 4 times negative 5 to the n minus 1. Now, I will encourage you, if you attempted number 2 by yourself, you should have definitely tried number 3, and you would have noticed that number 3 is a little different. My numbers are actually getting smaller this time. So I have to ask myself, what am I multiplying by each time? Because I'm telling you right now, this is a geometric sequence. But Mr. O'Sullivan, why is it geometric? And what is wrong with my marker? I don't like it. Did this work? No, it didn't. No, that didn't work either. Okay, so with this example, we ask ourselves this to find our next 2 terms. We always take our second term, in this case the 8, and we look to see 8 divided by 16. If you do this on your calculator, you should get 1 over 2. That means I'm multiplying by 1/2 every single time. Because 8 times 1/2 is 4. I now do 4 times 1/2. 4 times 1/2 is 2. I now do 2 times 1/2, which gives me 1. Those are your next 2 terms. Again, I'm telling you right now that it was geometric. The reason why it's geometric is because I'm multiplying by 1/2 every single time. You are multiplying by 1/2. You can also say I'm dividing by 2 each time. That is the exact same answer. And that would be acceptable. Now, part B says, what is my common ratio? My common ratio is the number you're multiplying by each and every single time. In this case, I multiplied by a 1/2 every time. So I simply write R equals 1/2. Or as many of you students like to write it, 0.5. Both acceptable. And then last but not least, I write my formula. A sub n equals a sub 1 times r to the n minus 1. We put it all together. I get a sub n equals, I ask myself, what's my first term? What is the first term of my sequence? What am I starting at? And I go back and look, and I started with a 16. So you better start with a 16 down here. I ask myself what my common ratio was. And if we look at that previous example, it was a 1/2. And now I raise it to the n minus 1. This is your final answer. If you can hear me, take a break. Hi everyone, now we're back to the real world connection because the whole thing with sequences is that they are the most realistic part of the math course you're taking. Sequences pop up every single day, and sorry, brain freeze. So let's look at the real world connection. As I'm reading along, you should be paying attention and you should be reading along with me. Miss Townsend plans to double the amount of time she spends walking per day each week. Think of Miss Townsend walking around Prospect Park. She starts on week 1 walking 5 minutes per day. After 2 weeks, she then walks 10 minutes per day. Remember, ladies, look at your relationships. And after 3 weeks, she's walking 20 minutes per day, and so forth. Miss Townsend's getting a lot of walking in. But now, if you think about it, now she's walking in her house because, social distancing. So let's think about it that way. So the first thing I'm going to do is I'm actually going to write out those numbers that are in our question. 5, 10, and 20. I'm going to write those as a sequence above our question. You can write them wherever. It doesn't really matter. It's still going to give you the exact same answer. So I'm going to ask you, because part A says, write an explicit formula to represent Miss Townsend's walking plan. So the first thing we have to ask ourselves is, how do I get from a 5 to a 10? I multiply by a 2. How do I get from a 10 to a 20? I multiply by, you guessed it, a 2. That is all I need to do part A. That is all I need to write my explicit formula. So I'm going to zoom in so I can do some writing. I'm now going to erase all of this beautiful work. And we're going to write the formula. Remember, our explicit formula is a sub n equals a sub 1 times r to the n minus 1. If you remember, our first term was a 5, and our r is the number we're multiplying by each time. So in this case, we're multiplying by a 2, or we're doubling. Make sure you know that 2 means doubling, 3 means tripling, 4 means quadrupling, 5 doubling means multiplying by 5. And then we always do this, our n minus 1. That is your final answer for part A. For part B, it says if she keeps this up, how long will she be walking on week 10? What that means is, I want to find out what the 10th term is. But the thing is, what I would like you all to do is to use your explicit formula. So in this instance, we're going to be doing a sub 10 equals 5, parenthesis 2 to the 10 minus 1. You can just type this into your handy dandy calculator as it's written, and you'll get an answer. I'll give you that answer in a moment because I need to take out my calculator. Awkward silence. So how's everyone's day going? It's very lonely on the remote learning. So I have 5 parenthesis 2 to the 10 minus 1, and I get 2,560. That means Miss Townsend will be walking 2,560 minutes per day. So I'm not going to write anything for part C. This can just be sort of like a little think aloud. Part C says, is your answer to part B realistic? Explain. So let's look at that question. This is where I would ask you to actually have a little quick think, pair, share with your partners in class. Look at the question. We want to figure out how many minutes Miss Townsend will be walking per day. If we look at this question, in the 10th week, she'll be walking 2,560 minutes per day. Just to give you ladies a heads up, there are 1,440 minutes in a day. Is it possible for someone to walk 2,560 minutes? No, it's not. So our answer to part B is actually not realistic because, one, it's not physically possible to keep on walking for 2,560 minutes. You'd need a little sleep. So, again, your answer to part B is not realistic. If you have any questions, try to walk for 2,560 minutes and then get back to me. That is your lesson on geometric sequences. If you have any questions, please don't hesitate to email me. You have my email. It's on the Google Classroom. And don't forget to pose one question for your participation. If you have any questions, you'll be completing some independent practice. Make sure you take a picture on a sheet of paper and submit it to the Google Classroom. Happy quarantine, ladies.